Okay, good evening everyone and welcome to my hometown. So last year I did start this meeting myself with friends, with my friends from Quobis and all the sponsors, and I'm really happy to see that this event is working organically and taking its own life. Just wanted to say that my name is Victor Pascual. I've been involved in WebRTC from the very early days since we started the initial BOF meeting at the ITF and then doing some backend work with Google, Ericsson, and some other companies on that. And I was invited today to just provide a very quick, like 10 minutes or 15 minutes, standards overview. So you will have to suffer across this before going to the beers. So there is a good sentence that I always like reminding myself when I talk about standards, is that the good thing about the standards is that there are so many that you can choose from. So this is one of the beauty of the standards. And well, this is the typical joke about the standardization. Disclosure, I do work for Oracle, but all the nonsense and stupid things I say today are just my own fault, nothing to do with my company. And yeah, who is somehow related to WebRTC standardization or know what's going on where? So basically, there are a number of players which are involved in the WebRTC scene. Some are providing value, some others just want to be part of the picture, just to get some press releases. So hopefully today we will have some consistent discussion. So basically the two organizations which are developing the core work on WebRTC are the ITF, which is the Internet Engineering Task Force, and the W3C. So today I'm going to go in a deeper detail on the ITF, as we have here Dominic, who's working on W3C. So basically he will provide very good insight on the APIs that W3C is developing. Then we have those guys that are taking the technology that the ITF and the W3C are producing and are trying to incorporate this technology into their existing architectures. And this is what the 3GPP is doing. So we'll go over what 3GPP is also doing on that. And then we have a number of organizations which are also doing some activities around WebRTC. There is something I would like to highlight, which is the GSMA. And here we are happy to have today each one. And these guys are spending a lot of time trying to understand what is the role of this technology in the service provider space and how to monetize this and what is the value operators can get from that. And basically, I'm sure that each one will be able to share today very good information on that aspect. So when it comes to the W3C, I mentioned Dominic will take care of this. So basically, they are working on the peer connection API, the data channel, and the get user media. There are some discussions about ORTC, whether they should be depending on SDP offer answer or not. Dominic, I'm sure he will provide a very good explanation on that. But basically, the W3C is defining the APIs that web browsers are implementing and exposing them to JavaScript developers, and so they can get access to all the WebRTC capabilities. Then we have the ITF, which basically means flying somewhere an entire week, drinking a lot of coffee, having some very strange discussions, and then not getting any consensus, and then having to do some mailing list discussions afterwards. This is basically my experience with ITF, where basically at the ITF, the work we have been doing is defining the protocol stack for WebRTC. So the W3C, as I mentioned, they define the APIs that web developers, that they have, in some cases, no clue about real-time communication. So basically, there are a number of APIs. They are producing applications. And this is all the magic which is happening underneath the APIs in terms of get me this codec or open this port for sending encrypted media, etc. So basically, what the ITF is defining is which are the codecs we are using, how is the encryption working on the audio and video plane, how is the key exchange mechanism for doing this in a secure manner, what are the security threats for that, what is the forward error corrections that we should be using for WebRTC, etc. And if you guys go to the ITF website for WebRTC, which is called RTC Web, you will see that there are a number of internet drafts which have been already discussed for a while. So here, there are a couple of documents which have been already published as RFC. So basically at the ITF, what you do is you write an internet draft, which is this strange ASCII document with strange diagrams. This document is discussed, and then if there is agreement in the working group, it gets adopted by the working group. This is the usual path. And then when it gets adopted to the working group, then it finally gets published as an RFC. So far, we have published as an RFC the use cases and requirements for WebRTC. This is basically one of the very initial documents where we were discussing, okay, so this WebRTC thing, what is this really about, right? Then there is also an RFC published on the stand consent freshness. Basically, this is about how the stand traffic can be sent or not based on the authorization, etc. And then there are a number of documents which are, here you can see the RFC editor's queue. These are documents which we already have agreement that, okay, so this is ready to go. And now we need to follow like a process before it gets published officially as an RFC. So here you can see basically the two specifications about the data channel. So WebRTC is not only about voice and video. We also have a peer-to-peer capability, which is a data channel, which runs over SCTP, TLS. We don't need to go into details, but basically here is where you see the details for this protocol. We have another document, which is how you use RTP here. So you guys, most of you are operating SIP-based networks, and you are using RTP. So here we are defining, okay, what is this profile for RTP that we should be using? Is it using also RTCP feedback? Should it be also encrypted? Shall we multiplex that into the same port? Shall we use different ports? So this is where we are defining that. And then it's also the video document, which is basically defining which are the video codecs that WebRTC should be using. If you have been following the discussion, we had lots of discussions around, okay, so whether we should be using BP8 or H.264, when at the end of the day, I like to explain this, that some lawyers started coming to the ITF, and then we realized it was not a technical discussion anymore, so it was just a royalties discussion. We had some battles back and forth, and then the final conclusion was that both BP8 and H.264 should be supporting for WebRTC. But my personal feeling is that, well, this is just a starting battle, because now we need to discuss about H.265 and BP9 and what's going to happen beyond that. So basically, it's just the starting point. Then there are some other documents which are in the ISG processing, which means the clever guys of the ITF are reviewing before approving these documents to be published as an RFC. First of all, we have the RTC Web audio. Basically, here we're defining the mandatory to implement audio codecs for WebRTC. The agreement is to use 711 and Opus. We decided to do 711 for backward compatibilities, but well, in most of the cases you are seeing in deployments Opus being used. But then some folks from the telco industry, being led by Orange France Telecom, they did publish also a document which is basically defining what are the, okay, so we are using 711 and Opus, but are there any other codecs which might be relevant for some scenarios like mobile networks or access to IMS networks, etc., that might provide kind of recommendations to implement other codecs beyond that, like 722 or some other codecs which are being used in mobile networks. So basically, the RTC Web audio is defining what's mandatory to implement, and the audio codecs for interop are defining, okay, so these are the recommendations that you might want to implement this if you need to interop with some other domains and you don't want to do transcoding. There are also a couple of documents right by KR on security, basically analyzing the security threats for WebRTC, what is the architecture, the identity provider role in the architecture, etc. And then there are some other active drafts, which basically are the ones which are having more discussion. Some are more major than others. So at the top we have the ALPN, which basically is a mechanism for letting know a middle box, like could be an HTTP proxy or a firewall, saying, hey, this is going to be a WebRTC call. Please let my media go through. This is not working yet in the real world, so this is something we're working on. But there are some other mechanisms today being deployed for this. There are some other documents defining the constraints. This is the interaction with the Get User Media API. There is an overview document. But basically, I wanted to here provide an overview. These are the core documents from the ITF perspective. And is there anything here that you guys are missing? So all I have explained here has to do with media, right? Nothing to do with signaling. Here we have discussed about the codecs, the keys, etc., but nothing to do with signaling. And the point here is that WebRTC does not define signaling. It does define how the signaling layer should be interacting. This is the reaction from some of our customers when we tell them. So we define in the JSEP how the signaling plane should be interacting with the APIs, etc. But for WebRTC, you can use HTTP, you can use SIP, you can use XMPP, whatever protocol you might want to use for that. This is what comes from the ITF. So basically what I wanted to point out is that W3C, Dominic, they are defining what are the APIs that web developers are using. the ITF is defining the media profile. This doesn't need to be a browser. Could be a mobile application, could be a fax if you want to call it. So this is basically a media profile that any device, preferably a browser, should be implementing in order to be WebRTC compliant. And then we have the interaction with the signaling server and some other peers, which is not defined. So basically you can take whatever you feel comfortable with. There are some standardized mechanisms like zip WebSockets or XMPP WebSockets, but we are, for instance, at Oracle doing JSON, so it really depends on what's the scenario you might be using. And then finally, I think that I'm running out of time, the 3GPP, which is basically the group that created IMS. I'm not sure how many of you are familiar with IMS, but this is the foundation for faulty voice over Wi-Fi and other solutions. This is really, really complex if you really want to go the 3GPP path. Fortunately, some in the industry have simplified this to make it work. And basically, if you take a look at the IMS architecture with support for WebRTC, there isn't anything really, really new. So basically, we had in the past something called the PCSCF, which is basically the signaling server. Now, in order to include WebRTC support, we just put an E in front of that, and this is enhanced PCSCF. Done. We had in the past something called the IMS Access Gateway. Basically, this is the media node for IMS. We put there yet another E in front of that, doing all the functions for like TTL SSRTP termination, transcoding, etc. So here, this is how it fits into the architecture. And then there are new components. So for instance, you can see on the top the WSF, which is basically the web server that you are using. And there are other components in the backend, like the WAF, the WebRTC authentication function, which basically guys from Quobis are implementing, which basically is providing interaction from what's happening in the access network and what you guys have in the core IMS network, like in the HSS, HLRs, etc. And this is pretty much from the ITF and 3GPP perspective. I hand over to Dominic. I'm sure he will provide insight on the WebRTC. Thank you.
Okay, hi everyone. My name is Dominique Azalmassieu. I work for WCC, the World Wide Web Consortium. And in WCC, I'm in particular responsible for getting the WebRTC APIs to standardization, which hopefully will happen at some point. So you can reach me at dom@wc.org. You can follow me on Twitter as Don't Call Me Dom. And a very quick introduction of what WCC is. So WCC is a consortium. We are a membership-based organization. We have more than 400 members from a big set of the industry, both big and small players. We have obviously all the big names, Google, Mozilla, Apple, Microsoft, and so on. But we also have plenty of smaller enterprises. Everybody in WCC has the same rights, so that's a fairly empowering organization. WCC was founded by Tim Berners-Lee, who I hope most of you know, created the web some 26 years ago. WCC works mostly with contribution from its members, but it's also animated by a staff of some 80 persons, from which I'm a member of. So we have offices in Europe, US, and Asia. So WCC is the organization that creates and develops standards for the web. So I'm sure you've heard about HTML5, CSS, a lot of JavaScript APIs. Some of the specificities of WCC in the standardization space is that we ensure that all the standards we bring to the web are royalty-free. What that means is that if you create a browser, if you create a web application, you don't have to pay anything to anyone, and I can tell you it's not always very easy to keep that commitment, but we do our best. So my particular job in WCC is to ensure that, as I said, WebRTC, the API, as Victor described, the ITF deals with the protocols, and WCC deals with the JavaScript APIs in browsers. So my job is to make sure that at some point these APIs stop changing all the time. Sure, some of you have had to deal with some of the rapid change in the APIs you found in implementations, and I'm partly to blame for that, so sorry. So I wanted tonight to review some of the APIs that WCC has been working on, just to give you an update on where they are in terms of development, and also maybe to inform you about what's upcoming in this space that might be of interest to you. So obviously the first thing you need if you want to establish video audio communication is access to the microphone and camera. So that's Get User Media API for those of you that are developer. Knocking wood, it should get to candidate recommendation very soon. What candidate recommendation means is that we basically are not going to change anything to it. We just have a couple of issues to close, but that should be, well, maybe when I'm back from Barcelona, basically. Some of the changes that have appeared in that spec in the past few months haven't been reflected in implementation. So again, if you are a developer, you might see some changes in the upcoming few months, despite the fact that the spec itself is more or less done. But this should be fairly limited overall. Another spec the WebRTC working group has been developing is management of audio output devices. So if you want to get part of the sound to your headset versus the speakerphone, that's the API you would use. This one is less stable, but is getting some interesting momentum. I think it has landed in some version of Chrome. I'm not quite sure which one yet, but you'll see that coming very soon. And because it has actually been fairly often requested, it should hopefully stabilize also fairly soon. Another thing, the most popular request, I think, on the Chrome bug tracker has been to enable recording in the browser. That also is starting to stabilize. It has arrived in Chrome. It is partially available in Firefox. What that means is that when you capture the video and audio stream from the browser, you can save it as a file or transmit it as a recorded blog to anywhere you would like to. So it's a fairly useful feature even beyond WebRTC. I mean, it's useful in the context of real-time communication, but it's also just useful if you want to, say, record a video locally. So it is getting there, as I'm putting it up here. Once we put the seal on Get User Media, I expect this is the spec that will get the most attention from the group. So of course, WebRTC, most of you will be familiar with the fact that, well, you need to establish a connection. Most of the time it will be a peer-to-peer connection, a direct peer-to-peer connection between clients. And that's what the core WebRTC API enables with the RTC peer connection object. It has gone through a lot of changes recently, and again, among the developers among you will hate me for that, but we had to go through this. Hopefully, we are mostly done now. I mean, we still have a few issues. There will still be a few changes, but we don't expect any critical new changes. We are basically in feature freeze. We are trying to close a few issues we know remain on the spec. And I'm, again, hoping to bring this to this candidate recommendation stage in the upcoming few weeks, maybe a couple of months. So that's a pretty big milestone. I mean, WebRTC, the WebRTC 1.0 API is probably one of the top most complex APIs WCC has had to develop. And it's also something that deals with a lot of layers in the stack. So it's a pretty big beast, but yeah, we're getting there. So who among you are familiar with ORTC? Can you raise your hand quickly? So ORTC is an alternative approach, an alternative API that Microsoft and others had been developing. Microsoft has also indicated that this would be the API they are interested in implementing in Microsoft Edge. And so some of the work we've been doing over the past few months, as Victor said, too many standards is probably not the best thing you can get. So one of the things we've been doing, and one of the reasons there has been a number of changes in the past few months, is that we are trying to converge with ORTC as much as possible. So the first version of the WebRTC API, the one that I'm saying is stabilizing now, has already imported some of the ideas from ORTC, but not all of them. And as I'll describe later, part of the work we will be doing in the next version of the API will be to finalize that convergence. The main difference between ORTC and WebRTC, without getting into low-level details, is that WebRTC relies very strongly on SDP for exchanging information about the local environment. And WebRTC says you don't need SDP, which I think most of the WebRTC working group has come to agree with. So we are nearly done. Again, not all of the changes that have been brought to the spec have been reflected in the implementation. So again, you'll probably see more breakage in the upcoming few months, but hopefully much fewer than before and very few after that. As Victor described, WebRTC is not just about exchanging video. We can also exchange data with RTC data channel. That part is actually, so it's part of the main spec. It's very stable, widely implemented. Basically, it's done. You shouldn't see any changes there. One of the things we are considering, based on very strong feedback from the developers, is making this data channel working inside workers, so basically inside background threads in browsers. There is also a request to make it working in service worker, which is yet another story. So that's basically the only open question about that part of the technology stack. Something that probably very few of you know is that WebRTC has also an identity management system integrated. One of the reasons you wouldn't know about this is that it hasn't been implemented yet. But it's fairly powerful. In a peer-to-peer environment, if you want to guarantee end-to-end encryption, you need to make sure that the person you're talking with is the person you think you're talking with. And that's what this identity mechanism solves, and it can do that even if the website you use for your WebRTC application is considered to be an adversary. So that's a really powerful system. It enables some really interesting advanced use cases in terms of privacy and security. It's fairly stable, but again, since we haven't seen implementations, it's still fairly theoretical as well. I think we will see the first implementations landing in Firefox hopefully soon. So you can exchange, obviously, video you capture from your camera, but you can also exchange stuff you would capture from either the current web page. So say you have a video playing in your web page and you want to transmit it over WebRTC. We have a spec for that. That's a media stream from DOM element spec. You can get it either from an HTML video element, audio element, or a canvas. So canvas is basically a graphic element in HTML. So that's a fairly powerful mechanism that we are also bringing to WebRTC. That part is not quite done. There are still some interesting questions, but it's getting there. We hopefully will be able to finalize it once we get over with Get User Media. The other spec that I'm sure many WebRTC applications implementers are interested in is screen capture, so the ability to transmit what you get from either an existing window or even the entirety of the screen and transmit it over WebRTC. If you're building a collaborative application, that's a very classical use case. We have stabilized that spec. It's actually already available in browsers, but again, for any of you that might have implemented it, you know that you require usually an extension to make it work. There are some really difficult security questions about enabling screen sharing. And finding the right trade-off, the right balance between this security and the convenience both to the user and to the application developer remains difficult. So we hope we'll be able to make progress, but so far it's not clear that we have found the right solution. So it might be that we are stuck with this middle ground for some while. So that's the basic landscape of the APIs on which the WebRTC working group is working. There are many other specs in the web that are actually relevant to WebRTC applications, like the fact that nowadays you can use push notifications in browsers. This has arrived in Chrome. It's recently landed in Firefox as well. Basically, it means you can actually ring a phone based on a WebRTC call, so that's a fairly powerful mechanism. You have offline support with service worker and well, many others. I mean, the WCC is working on the whole web platform, and we have quite a bit of ongoing work in general. And WebRTC obviously benefits from all of this additional work. I'm sure most of you know of this, is WebRTCReadyYet.com. If you want to know what's implemented in what browser, that's a very good reference. Most of you will notice the right-hand side column under Safari with a lot of red. There was some recent noise that Apple is looking to hire WebRTC developers for presumably implementing this in Safari.
Only one?
Developers, for sure. Well, or if we want to see this in the upcoming few months rather than years. And they also put it as in development on WebKit, so hopefully the big question that I get all the time will soon have a different answer. The current answer is, I don't know, and hopefully in the upcoming few months, the answer will be yes to the question as to whether Safari will implement WebRTC. Microsoft, as I indicated right now, is implementing the alternative approach, ORTC. The idea is that you can actually implement WebRTC on top of ORTC, so that you can have a polyfill to bridge the two specs. But some of it has been demonstrated, but not all of it yet. What's next? So as I said, we are finalizing 1.0, the first version of the spec. We'll soon, as soon as we are basically in candidate recommendation with 1.0, we'll start on the next version, which doesn't have a name yet. And one of the major goals of that next version is to finalize that convergence between the WebRTC and ORTC APIs, again, to avoid this proliferation of standards. As I mentioned earlier, there are some interesting discussions as to whether the data channel should be available more broadly than it is currently. So what this Sibyllin sentence data channel in Service Worker means is enabling peer-to-peer application even when the browser itself is not running. Very tricky security questions again, but also some interesting use cases. We already have an ongoing spec for enabling capture of 3D videos in the browser, with 3D cameras coming to devices that also is likely to prove interesting. So that's capturing 3D video, it's not yet transmitting it over WebRTC because that's still a research problem. As I mentioned earlier, the LCC is a consortium. What that means is that any organization can choose to join the LCC and participate to our activities. So whether you're big or small, whether you have a lot of existing activities in space or not, the LCC is an open organization. All of the specs that I've mentioned and most of the specs the LCC work on nowadays are developed in GitHub. So again, if you're so inclined, that means you can follow what is being worked on. You can even contribute patches through pull requests. You can raise issues if you have feedback on how the spec works and so on. So please do so. And also all of the work we're doing here happens on public mailing lists. So if you're not scared of getting way too much email, you can also join the fun and subscribe to our mailing list. And that's all I had for you tonight. And obviously, if you have any questions, we can look at them during the panel. Thank you.
Okay, hello everyone, good evening. My name is Istan. Actually, I'm working for the GSM Association. I'd like to give you a brief introduction before I jump into the slides and give you some heads up. And I am very excited to share actually one of the important news actually we've been working on for quite a while. So GSMA is a trade association and has been established some 30 years ago by large mobile operators. And the main purpose of that was to kind of allow them to work collaboratively without putting all the sort of competition aside and sorting out technical issues and basically agreeing about items like international roaming and things like that on a technical and also on the commercial front. Basically, today our trade association has grown so far. We have 800 mobile operators and approximately 200 associate members working actively with us. And those associate members, actually, many of the companies, actually, you are sitting in this room today. Large sort of enterprises, chipset vendors, terminal vendors, equipment manufacturers, software developers, and the like. We have actually the pleasure of Facebook joining us in 2015 March, so that was a great and big deal for us. In the association, we've been working on several areas, and we have something called Vision 2020 program, which kind of encompasses 4 main program activities. One of them is focusing on digital commerce. Another one is basically personal data, which solves the problem of Mobile Connect, actually a product we have jointly developed with operators and associate members. The third one is Network 2020, where the guys are focusing on network evolution, looking at the current 4G, 4G+, and even the 5G specification. And the last area is the focus is Internet of Things, is called Connected Living. So we have quite a large team focusing on these particular areas, like looking at the verticals like e-health and smart cities and automotive and all other areas like this. So that's just a kind of brief introduction before I jump into the details, which will become more important when I talk you through exactly what we have done and what is the current plan of record today. So basically what we've done, I think I've been talking to many of you about the activities we have been doing within GSMA about WebRTC particularly. So WebRTC has been an interesting technology for many of the operators quite some time ago. So back in 2014, actually, we started looking into this technology, understanding what are the pros and cons, what it means actually for operators. Are there opportunities or threats? If those actually, what are those actually, if there are any? And that was unfortunately agreed by one of our board supporting organization that this information should stay within the community because it was unclear where operators really want to go with this technology particularly. There are instances actually back in early days when operators took the risk and implemented something, which I will be talking to you actually about later. But I think it was just a one-off. It was actually just a kind of slightly different strategy some of these operators have taken. So it is just a kind of really, really high level actually I want to talk to you about, you know, those particular topics. And then later on actually we started approximately 10 months ago to develop another sort of white paper and kind of based upon that first finding, which was only shared internally, try to answer the question about so what? So what does WebRTC really mean for operators 2 years down the line? So the first paper actually, the reason was kind of issued internally to sort of give perspective about this is what the technology can do. These are the opportunities, as many operators were afraid about taking risks for many reasons. First and foremost, you heard about the standards. I think it was absolutely diabolical, I would say. You know, nothing was locked down. 3GPP actually was also dragging their heels, shall we say. You know, the shorts and sandals guys actually, you know, minimum age was 50 plus, just to give you a bit more idea about it. But anyway, so I think that was the reason why we decided approximately 10 months ago to go into a little bit more detail and understand technology is a bit more mature. We know exactly what opportunities there are. We've seen many examples actually out in the industry, in the ecosystem, what has been implemented, and what are the real opportunities actually for operators. So this is what was the purpose. We wanted to really answer this question. And we also realized during this exercise, many operators have joined this effort approximately 10 months ago, as I said, we started jointly, and they all kind of made aware or made their recommendation or implementations sort of public, and they really were vocal about saying, yeah, we have taken the opportunity to implement something and leverage this technology to a great detail, extending our services. And I think it was really, really a good point. And I think the last couple of items, I think it's just WebRTC is still evolving, you know, shall we say, because I think we know the specs are almost done, but not necessarily. And I think we knew about the sort of issues in the IETF side regarding the codec debates and some signaling issues and so on and so forth. We're still ongoing. And, but I think the conclusion is we have developed some ideas and strategic options. and identified what are the real opportunities actually for mobile operators going forward. So how can they really add value and what it means for them. So just a little bit about this 2014 white paper, which I can share some insight with you about what we've kind of looked at. So I think you sort of really went into real detail by looking at the standards at that time, looking at IETF, and IETF and W3C in particular, exactly where they are, what that technology can do. Looked at the particular use cases, what it means, for operators in the B2B and the B2C sort of side, and also had interviewed vendors, our associate members, about, guys, tell us what you have, what solutions that are available, like gateways or anything like that. Are there any pros and cons? How would they work? What is the lowest common denominator? What values operators would then kind of get out of that? How much is the risk actually they need to take, and so on and so forth, to try to answer those basic questions. And then we also looked at the browser support. At that time, I think it was a bit patchy, shall we say, back in 2014, sort of middle of 2014 even. And it was a codec debate. It was a constantly ongoing codec debates about whether it's H.264 or VP8, which I think was resolved at the end, sort of early last year. And then we looked at possible implementation options, but I think it was pretty much up in the air about what it would mean for operators. It was pretty much just a kind of ongoing debate. So we didn't, or could not really conclude about what this technology can really provide for operators. So these were the key points. So it didn't really answer the question, so what it means. So that was really the sort of drive for this newest white paper we started about 10 months ago. And I think we also learned that specs are still being worked on. I think Dom also referred to this website we've been keep tracking on about is WebRTC ready yet. I think it's a good indication about where we are in terms of browser support. Large-scale OEMs have developed gateways, but they all have different implementations. So one of them preferred JavaScript APIs, another bunch preferred REST APIs. And I think it was kind of a fragmentation of that particular implementation. And cloud service providers offered limited services at that time, back in the middle of 2014. There was no real interoperability or breakout, if you like. Operators' implementations were in early stage. I think what we have seen at that time was just a telco OTT play, which I will go into a little bit more detail later on. So what this white paper we've started doing was, we have actually just published this morning, so I'm very pleased to say it has been externally made available. So if you are interested, there is a URL. I think you can get access to these slides. Please go and have a look. And it kind of contains good source of information about our findings, which is a collaborative work with 15 mobile operators and quite a few associate members, quite a few vendor gateway providers, and also some of the cloud service providers we have got. And the focus areas were about strategic views and looking at how future-proof WebRTC is in the current network infrastructure and what it means actually for 5G. I think you know the fact in 4G, actually, the 3GPP guys have decided to take voice out, hence why we have VoIP. And I think it was a real big question about what it does mean in the 5G environment. The specifications are being worked on, and even discussions started about what it means. I think we wanted to make sure some sort of real-time communication will be part of that discussion as such. We looked at additional use cases, not just the sort of box standard B2B and B2C. We looked at actually the Internet of Things. We looked at actually how peer-to-peer communication can leverage data channels only. How can actually peers can exchange files or information, without even sort of using the communication angle, i.e. the audio and the video parts. Looking at the existing standards, how far they have got developed, and what are the real opportunities for next version, how we as a trade association can influence actually the standards going forward as a community, because I think it was missed in the first version or version 1.0. And also looked at different implementation options. So our learning was actually just to kind of summarize what that paper actually means in a few bullet points. It saves you reading. It's quite a large paper, about 30 plus pages. Focusing on strategic and business options, so it highlights the opportunities, what operators can really do, or service providers, let me put it this way, can do with WebRTC as a technology. There are several options. There's no one-size-fits-all. I think that was a clear message. and also alignment about the existing and the evolving technologies, mobile technologies such as 4G and 5G, and also opportunities for the next version. So what does ORTC will mean? You know, how is it going to influence the standards going forward, and how operators can be actively participating in these discussions. Many more service providers offer commercial grade services. I think basically the WebRTC technology definitely started taking off, and it made more presence. I think it's carrying more traffic than 12 months ago. And I think the 3GPP guys have already defined actually the implementation into existing IMS networks. So I think they will be probably more likely looking at actually when the next version is coming out, the evolution of that. Suggesting new use cases, as I mentioned, the data channel side of things, in particular the machine to human, human to machine, and even the machine to machine communication side of things. And I think it's a flurry of options, not just one size fits all. So I think it kind of provides ideas about, you know, what if, you know, operators really want to kind of extend IMS services? What if operators really want to kind of go down the route of telco OTT play, for example, and so on and so forth. So just to give you some ideas, so these are concrete implementation examples we have actually learned in the last, sort of as part of the last paper development. I think AT&T have launched their WebRTC API on January 3rd, 2015. I think it's been going pretty well. We've been keeping track with the developer team about what's going on regarding that particular front, and they're offering quite a large or broad areas of services for developers as such, including enhancements regarding the E911, SIP trunking, and all other good services like that, which is actually for a small fee. For a developer is real value, because I think they can enhance actually WebRTC technology, if you like, and really turn it to a fully fledged communication service with those particular features. Telefonica Tokbox, I think, needless to say, I think we're going to hear a bit more about it today. And I think it's a great idea, again, how a mobile operator have taken the risk and sort of acquired a startup, if you like, you know, which had become pretty successful with the teleconferencing platform, and how they evolved that particular service. And now they've taken it to, or trying to take it to consumer space. I think that was really the key kind of point for that. Orange had a service, something similar to Skype, and they started nurturing it in the last sort of couple of years, and in the last 3 months or so, they decided to put their Libon 3.0 version, which is sort of a WebRTC powered solution. So I think they're trying to kind of go down that route as well. Deutsche Telekom actually just launched in November a sort of service which is called the Home Talk. This is kind of more focusing on a fixed line solution, so it's a dedicated app and allows you to use more your application as a fixed line service, and they offer also customer services leveraging WebRTC. NTT KDDI, the Japanese, have got great ideas, and I think they launched services over 12 months ago. And finally, Tata Communication, which I didn't know much about it. I think they also contributed this development of the latest white paper we just released. They also kind of started offering teleconferencing services to their particular business customers in the last 6 months or so. So I think that's pretty much just a kind of brief summary I wanted to share with you, and I'm more than happy to answer any questions, should you have any. Thank you.
All right. Thank you, guys. And let's give everyone just a quick one more round of applause for everybody. Okay, now you guys are on stage. So, questions. This is about the community, so please, this is about you guys asking questions. Victor doesn't bite, so you can.
Are you sure?
Hello, everybody. I actually mentioned this to Victor before coming in. We are an operator here in Spain. Our name is Masvoz. We offer B2B services. So our business case is pretty much the one that Isvan mentioned previously, the WebRTC to IP PBX, right? And we have a product which is what we call a web phone, which is self-explanatory, obviously. Now, what we find is that depending on the environment where you deploy it, you know, it works fantastically well, but the challenge we find is achieving a good quality of service in environments where, you know, the network is not so well controlled, or the computers have some software, running on it that may slow things down, etc. So what I wanted to know is what type of efforts are being made, if any, in terms of QoS in order to achieve, a consistent or a good experience for users that does not depend so much on the specific computer, because what we find is that, for example, when in the case of an IPPBX, when you deploy a physical terminal, you can have, in principle, far more control in terms of quality, I suppose, when you are running over a computer. So I wanted to know what the view is, or what efforts are being made, etc., in terms of standardization or whatever. Thank you.
Want to take this one?
Well, as my friend Alan Quell would say, why do you need QoS when you have Opus, right? So basically, when it comes from the ITS perspective, there were some discussions on that. Even we produced a document which is discussing the concept of deploying local turn servers. This was meant initially for privacy reasons and doing firewall traversal and so on. There are some guys which are taking a look at this because of QoS, but I'm not sure whether, Isman, you have more background on whether operators are trying to put in place any kind of QoS mechanism for this.
It really depends. I mean, it really depends on the circumstances. We start looking into that from a technical perspective. So this is a kind of business and strategic focus paper I think we just published, and the predecessor of this was a lot more in depth, talking about technology per se. And I think QoS was kind of mentioned as a means of providing sort of enhanced communication, because I think cause is not necessarily a given. So it depends on the circumstances, it depends on the radio conditions, it depends on the network criteria, the interconnectivity, and so on and so forth. So we could not really define a framework, that's my honest answer, to say this is the minimum sort of expected. But if there's a need, I mean, we are not making standards in GSME, we are making recommendations which most of our operators follow, then it would be an opportunity, definitely, because of the scale and also the demand and the support we have to kind of define something like that. So there's an opportunity, doesn't exist today.
And I guess I'll just paint that too. Victor, you had said that why do you need QoS when you got Opus? We've been doing a lot of testing with VP9, and VP9 is a very resilient codec. So it actually operates under 30 to 40% less bit rate, and it's just as good quality. So it's a very resilient codec. What else, guys? Questions?
Thank you. I don't know if this was addressed before because I arrived a little bit late, but what about NAT piercing? There's a problem with routers and all the connections going in and out. This problem has been solved more or less, or there's still things going on in the spec, or is it something that has to be handled by the user? Thank you.
You mean NAT traversal?
Yes, sorry.
Yeah, basically in traditional networks, one was going through NATs because some network element was just accepting a connection, so you did an active open from the inside, and then this connection was kept open, so you can send traffic inbound and outbound. This is something we have been working on the ITF, and basically as part of the WebRTC specs, it's mandatory to use a mechanism called ICE. ICE makes use of stand and turn, and basically this is a mechanism we can follow up offline if you have interest, which basically enables whether the two parties can, in a peer-to-peer manner, discover each other, and if peer-to-peer traffic really is not going through, what you can use is a network-based relay as a last resort. So basically what you do is you take your local IP address, you try to go to an internet-based reflector where you, in a stand server, where you see what's the public IP address others are seeing from you, and then you can allocate in a turn server some resources just in case this is not working. And then you send all this information in the SDP or whatever structure that finally we end up using in the next version. And then your peer then is doing some kind of connectivity check saying, okay, so I will try whether I can reach this guy directly. And then if it doesn't work, I will go through the turn server. Having said that, there is a real world problem, which means going through middle boxes, like could be HTTP proxies, like could be more strict firewalls, which is these things are not working. For that, this is something we have already addressed at the ITF, which was basically failing back to TCP-based traffic. So this means sending voice and video over a TCP connection. Of course, this has its own challenges, but as it looks today, basically it's a mechanism which you're making the network believe that this is yet another, if you want to call it, HTTP connection, and then you can go through all these middle boxes. Does it respond to your question? Yeah. Okay.
Tom, I have a question for you. You talked about screen sharing, and whenever I typically present to a customer, one of the buzzwords around WebRTC is pluginless, but it's not in that case. So you had mentioned concerns, security concerns, obstacles. Maybe talk a little bit about that for us and what you're seeing as far as the concerns go, and maybe how do we get around that as a community?
So the concern is, on the web, you don't install anything. Basically, when you go to a website, you don't presume that there is any trust relationship with the website you're visiting. I mean, if you click on a link on Twitter, well, you know, it's t.co. That doesn't tell you much about where you're going to land. And what that means is that the web operates in a security model where basically you never trust the website by default. And before you trust the website, you'll have to gain confidence that this is a reasonable request. So typically when we ask for access to the camera and the microphone, the user gets prompted, would you like to share your camera and microphone with foo.com. And that's probably acceptable because users understand what are the privacy and security risks linked to sharing their video and audio feed. But when it comes to screen sharing, it becomes a lot more complex. First, most users don't understand what is on their screen. Say you have two windows, one overlapping the other. Will I be sharing the two windows, only the one that is visible? Will I be asking to the user to select which of the window will be shown? And so that's already a first complication. And there is a second complication, which is the web operates in a model where a website has to be strictly isolated by default from other websites, typically because you don't want your intranet content to appear on any random website. So that's what we call the same origin policy. And once you start sharing your screen and sharing, among other things, other tabs, other windows of your browser, you're completely breaking that model. And so basically trying to explain this, which maybe half of you already didn't quite grasp because it's complex, to random users who just want to go on with their lives, if you start prompting them, asking them, would you like to they'll click yes. And you won't have achieved much. So basically, the solution we have at the moment is that we have defined this elevated model of privileges that the websites require us to use screen sharing. And the way browsers have implemented it so far is that they have, not a plugin, but indeed an extension that you have to install, which basically represents the additional trust that the user has to give to the given website. And we hope that we can get to a better model. I mean, there are already some interesting discussions on how a website or a web app can elevate its privileges. For instance, the way websites get added to the home screen or gets more offline storage and so on. So we think there is a way, and we hope we'll find the right balance between asking relevant questions to the user and also making screen sharing an actual plugin-less feature. But it's not just defining an API in this case. It's a lot of UX research, a lot of security questions that needs to be solved, and that's the reason we're kind of stuck in the current situation.
Is there a way to communicate with for WebRTC to communicate with WebGL?
One of the specs I mentioned, the capture from DOM element, it lets you capture stuff from a canvas, and since WebGL basically operates inside a canvas, you can get the stuff from WebGL and then push it over to WebRTC.
The other way around.
Sure. I mean, so once you have a canvas, you can put any kind of web content in it, including videos that you would have gotten from WebRTC. So yes, you can definitely do that.
question's also for Dominique. Just out of curiosity, when you say that the specifications are theoretical, do you test them out yourselves on like a special browser, or?
That's an interesting question. So the way we develop our specs in WebRTC is extremely iterative. That is, we don't come up with, this is what you shall implement. But as I mentioned, all the browser vendors are part of WebRTC, and in fact, they are doing, again, a lot of the work that happens in WebRTC. So the way this works is, one of the guys will say, oh, I think this is the right way to do this, and another guy, oh no, this is completely bullshit. And at some point, we come to consensus, and they start implementing, experimenting, and there is this iterative loop. So in the case of the identity, we have more or less validated the principle, but it hasn't shipped in a browser. To me, that's until and unless it has shipped to a wide number of developers. To me, it's theory, because until we know whether people can actually make use of it, whether so in the case of identity, we have to integrate with identity providers that will act as a third-party validation of identity. Until we have verified that all the ecosystem works around this, it's a very smart mechanism, I must say. So that part of the spec is very nice, but until I've seen it, I'll call it theoretical, yes.
Hello, my name is Alexander, from Venezuela. I will try to speak English, but it's very difficult for me. Only speak Spanish. The people talk about three important things: the memory, the CPU process, and the security issues about to share the true IP by the standard and the service with the browser. If we can work to suggest to the browser to use better the memory and the process is very important thing. Another is suggest maybe the next year we can make use more the technology to share this event to the world, because we don't have real time. I make part of Mozilla community, and I share all information with the community in Latin America, but we don't have real time communication right now. And this is only three things: the suggest and what about the security issues, about the sharing very confidential information about the user in the browser.
So you were referring to the IP address issue, or?
Yeah. Streaming by to use the socket by the browser to share the IP information between IP cannot use proxy or VPN.
That's about the IP leaking problem.
Yeah, so just to introduce the issue to others that might not be aware of it. So there has been a lot of noise around the fact that once you have WebRTC in your browser can basically tell any website that asks nicely or not what are all the IP address that your device is working on, including private IP address, like the one that you would use on a local array network, but also including IP addresses that you would have thought were hidden by your VPN. And that can be problematic, especially if you're using a VPN to hide your real IP address. And that has been issue 179 on our GitHub repository, one that has given us quite a bit of work. I think we have now a solution, and the solution was also driven by the work on the IETF side. But basically the idea is that unless you're sharing your video and audio from your device, the IP addresses that your browser will be exposing will be restricted. And it can be even further restricted either by a specific configuration from the browser or by installing an extension or something like this. So basically, we've made it so that in the cases where it's obvious that the user is ready to share very sensitive information, their video and audio feed, we can share more information about the network context, including IP addresses that they would not have shared otherwise. But until that proof has been made, until that consent has been obtained, basically the IP addresses that are exposed are very limited in their possible reuse for nefarious purposes. So that's currently what has been decided. I think, not sure it has been implemented yet. It might have landed in Chrome.
There is an extension for some browsers for doing that.
And obviously, based on the feedback we get, I mean, again, there is a big trade-off here. One end of the spectrum is WebRTC works in most of the weirdest network situations a device can be in, and the other, the user is completely safe in terms of which IP addresses are revealed. And what we are trying to do is finding the right middle ground, and we have an idea. Hopefully, it will soon be implemented, and hopefully, you guys will start yelling at us as to whether this is the right solution or not. Did that answer your question, or?
Yes, perfect.
Great.
Talk about the streaming. So I believe we are streaming this. Otherwise, we're going to be putting it on YouTube for later use. So we should be streaming if not.
There's a streaming, but that's based on Flash.
You shouldn't have said the swear word, Victor.
That wasn't our decision. So I have a question. So I think 2 or 3 of you had referenced, is WebRTC ready yet? And if you're familiar with WebRTC, that is a link that you go to a lot. If you follow it over the past couple of years, it has not only gotten wider, but it's gotten longer.
Right.
And not only that, but you see pockets of green. That, to a developer, I think is a bit difficult to navigate which browsers use what and so on. I don't know if you guys can maybe address that in some of your discussions here.
So the reason the list has grown is that, as I mentioned, the WebRTC spec has changed quite a bit. So for keeping that table informative, I understand that the author has chosen to add new rows where we choose to add new features. Also, we had some very technical changes, typically changing the API from callback to promises, no matter what. And that's another row in that table. And the main question, though, is why is there so much green and yellow? Well, so little green, so much yellow and red. A lot of it is because, again, the spec has been evolving, so browsers have to catch up still quite a bit. But I think the longer-term answer, at least the answer I'll soon start to be working on again, is that WCC, as part of its process, before we call something a standard, I said we are soon going to be at the candidate recommendation stage, but the final stage in our standardization process is recommendation. And the path between the two is having a full test suite of the specifications that can demonstrate that every single feature has been implemented at least twice. So basically what I will soon be working on is developing a lot more test cases to actually have a much better picture as to what is correctly or not correctly implemented by which browser. And the day we put the final stamp on the spec is when we can demonstrate that enough of the spec has been implemented by enough independent browsers to claim that, well, this is no longer theory, it's actually a practical thing that anybody can rely on.
We have time for one more, if anybody has one.
Thank you, Vince. I actually have a simple one. You mentioned that the spec is not finalized yet, and is WebRTC ready yet? I just want to know if there is any date for finalizing the WebRTC.
So depends. It depends on what you call finalized, and it depends on what you call WebRTC. You've heard about the whole list of specs that is being developed at the IETF, the whole list of specs we are developing in WCC. I mean, the core API, the WebRTC 1.0 spec, that one, as I said, will reach candidate recommendation, again, hopefully in the upcoming couple of months. And it doesn't mean finalized because I'll still have a lot of work to do. But for most of the developers, it will mean nothing will change anymore. And again, it doesn't mean that the browsers will have caught up with the spec either. So I mean, calling something final is fairly difficult. And in the world we live in, at least in the web space, something that is final is basically something that is dead. I mean, ActiveX is final, I can tell you that. But WebRTC, not so soon. And as I said, we are finalizing the 1.0, but just so that we can start working on the next version. So, you live in a world of pain, but it's probably better than living in a dead world. So.
We just keep amplifying the question about 800 times to the standard bodies as well, sitting in the middle and trying not necessarily being dependent on these questions. I think in certain scenarios, I think is very important for us as well from that perspective. So I think it's a valid question, and we have been kind of collaborating with W3C and also the IETF guys, working very closely in collaboration, because I think the silliest thing would be for actually service providers to sit back and wait for something to happen, because I think either is going to happen actually in the favor of the browser implementations, not necessarily from the service provider's perspective. And also, if we work in collaboratively with these guys, we can achieve that goal much sooner. I think that's really the key point for me.
Also, I should say, one way to get stuff done is help. As I said, we work on GitHub. We welcome contributions. We welcome ideas and so on. And yell. Yell at browser vendors, yell at WebRTC, and each time I get to a developer event, I get this question, and that does influence my will to push on others to say, well, we have to stop at some point. So yeah, do let people know that at some point you need something stable to work on, because that actually changes stuff. So.
All right, thank you guys very, very much. If you guys don't mind giving them another round of applause. Thank you very much for your time and your great answers. Okay, so we're gonna take a quick break, 10-minute break. Go eat some more food, drink, bio break, whatever you need. 10 minutes, we'll be back, we'll re-rack, put 3 more ups there, and get going. So 10 minutes, please.